Hello class of 2018. Today's aims are to find the variance in standard deviation of a continuous random variable and to find the interquartile range of a continuous random variable. Now the basics are still true. The variance is called var x and it's e of x squared minus mu squared. You may have written it differently. You might have seen it as e of x squared minus the mean, which is e of x all squared. You need to be able to use both forms. The standard deviation is the square root of the variance, and generally 95% of all the values lie between two standard deviations of the mean. The interquartile range is the difference between a 75th percentile Q3 and a 25th percentile Q1. So it's worth putting this diagram in your notes. I'm using a bell curve, but it doesn't have to be a bell curve. The Q3 will be this number here. That says 3, right? And Q1 would be this number here, Q1. And if I do them separately, the 75th percentile, Q3, is defined as the integral from negative infinity, because we don't know if that goes on forever, to Q3 of f of x dx equaling 75 over 100. And for Q1, something like this. The integral from negative infinity to Q1 of f of x dx equals 25 over 100. And you'll need that for later. So let's find the variance and standard deviation for the random variable x, which has the PDF rule defined as this. So we'll start with e of x, which is the integral from 0 to 1 of x times f of x dx, which gives you 4x to the power of 4 from 0 to 1 dx, which gives you 4x 5 over 5 from 1 to 0, which is 4/5, 1 to the power of 5 minus 0 to the power of 5, which is 4/5. Next, we find e of x squared, which is the integral from start to finish of x squared times 4x cubed dx, which gives you 4x to the power of 5 dx, which means we are going to integrate, so we go x to the power of 6 over 6 times 4, square bracket 1, 0. We can simplify this a little bit. We can divide by 2, so I get 2/3. I can bring out the 2/3 as a common factor, giving me 1 to the power of 6 minus 0 to the power of 6, which gives me 2/3. So therefore, the variance of x is e of x squared minus e of x all squared, which is 2/3 minus 4/5 squared. Using my calculator, gives me 2 over 75. So we have the variance of x is 2 over 75. So then the standard deviation is the square root of 2 over 75, which is going to be square root of 275 is 3 times 25. So I can write it out as 5 root 2 root 3. Rationalize the denominator. I get root 6 over 15. And once again, you could have gone straight from here to here with your calculator, and that would be fine. Right, so we're going to find the interquartile range of the random variable x, which has a probability density function f of x. It's helpful to draw a little bit of a sketch to start with. And so we know it's a straight line from 0 to 1, and it's 0 everywhere else. And so your first quartile will be A, and your third quartile will be B, where the probability from 0 to A of f of x dx will equal 1/4 to start with. So let's integrate that. So we have 2 bracket x squared on 2 from 0 to A equals 1/4. These 2's will cancel, which is very convenient. So that gives us a squared minus 0 equals 1/4. A squared equals 1/4, so therefore A is equal to plus or minus 1/2. But because A is greater than 0, A has to equal 1/2. Or I can say A is between 0 and 1. If I find B, then I do the same thing, except I have from 0 to B of 2x dx equaling 3/4 for the third quartile. So we have the same integral again, and again we could do this by hand, by CAS calculator, but I'm just doing this by hand so you know what to do. I can cancel the 2's down. I get x squared from B to 0 equals 3/4. So we have B squared minus 0, which we don't have to write in, equals 3/4. So B is equal to plus or minus the square root of 3 on 2. Again, B is only the positive because B is between 0 and 1. And lucky last but not least, the interquartile range is B minus A. So we had from before root 3 on 2 minus 1 on 2, which we can simplify to one single expression like so.